Categorical propositions and their properties: quality, quantity, and distribution. A categorical proposition is a proposition that relates to classes or categories. There are exactly 4 standard form categorical propositions: all SRP, no SRP, some SRP, and some S are not P. The S term denotes the subject class, and it's called the subject term. P is the predicate term and denotes the predicate class. All, no, and some are our quantifiers. There are 3 of them. And are and are not are our 2 copula. They couple the subject and the predicate terms. We are going to get so familiar with these propositions that we're going to call them by their names. All SRP is called an A proposition. No SRP is an E proposition. Some SRP is an I proposition. And some S are not P is an O proposition. Now, these propositions have had these names for over 2,000 years. Aristotle originally named them this way. And if we were Aristotle students, we would be learning different rhymes and songs in order to keep track of the various different combinations of these propositions that can be used to form syllogisms that are, in fact, valid. Now, we are not going to do rhymes and songs. We're going to attempt to evaluate our arguments in a slightly different way. We're going to make use of Venn diagrams and rules. And in order to make use of those, we're going to need to learn some things about the properties of these propositions. So right now, all of this seems really basic, and it in fact is, but it will be important that you learn these features of these propositions. The first is quantity. Now, all and no are universal statements, right? So our A proposition, all SRP, makes a statement about every member of the S class, saying that they are, in fact, also members of the P class. While our E proposition, no SRP, is a universal statement saying that none of the members of the S class are members of the P class also. Our I and O propositions are particular. They simply make a statement that there's at least one member of the S class that is, or is not, a member of the P class. Now we're going to learn to read the word some as at least one. We'll get to that when we look at how we're going to interpret our Venn diagrams in a future video. Quality. A and I propositions are affirmative. All S are P, some S are P, right? They are both affirming that there are members, or at least one member of S that is also a member of P. Whereas E and O propositions are both negative. They are denying something about members of the S class. Now, distribution is slightly different. It is not a property of categorical propositions as a whole. It is a property of terms within a proposition. So, a term is distributed if the proposition in which it is found says something about every member of the class that it denotes. Now, in order to make sense of this, it will be helpful to get a clearer sense of what each one of these propositions actually means by looking at the Venn diagram that represents the meanings of these propositions. Let's start with the A proposition. The Venn diagram that represents what the A proposition means is this one. you'll notice that the whole area of the S class that is outside of the P class is shaded in. Now, the way that we are going to represent meaning in our Venn diagrams is that we are going to use shading to indicate that an area is empty. This might be slightly different from what you've done previously with Venn diagrams, so it may feel a little strange, but we will keep this consistent. Shading always means an area is empty. So let's look at this diagram. We're looking at the left circle, which represents the S class, the right circle represents the P class, and we see that the area where they do not overlap is empty, because we are told that all S are P, which means that every single thing, if it's in that S class, is in its intersection with the P class. Our E proposition shows us that the intersection of S and P classes is empty. That makes sense? What the E proposition says is that no S are P. Nothing is both an S and a P, so the intersection between the two is empty. So again, we have to keep in mind that a shaded area is an empty area according to our rules for representing categorical propositions in Venn diagrams. Our A and E propositions are universal, so they will make use of shading. The I proposition says that some S are P. That means there's at least one thing in the S class, and it is also in the P class. So we represent that by placing an X right in the intersection of the two classes to say that there is some object that belongs in both of the classes. Our O proposition says that there's at least one object that is in the S class that is not in the P class. So we represent that by placing an X in the S class, but outside of its intersection with the P class. We're going to have to get used to understanding some as at least one X exists, right? Or at least one such object exists. Again, we will look at that again and again. Our X's in our Venn diagram will always indicate that that area contains at least one element, and that's all it will indicate. It contains at least one element. Okay, so now we're ready to talk about distribution. An A proposition distributes its S term because that proposition says something about every member of the S class. In particular, it says that every member of the S class is also a member of the P class. An E proposition says something about every member of both S and P classes, so both terms are distributed. In particular, it says that there are absolutely no members of the S class that are members of the P class, and because we see that that intersection is empty, it must be the case then that there are also no members of the P class that are members of the S class. So it's telling us something about every member of both classes. Both terms are distributed. The I proposition, well, all of it tells us is that there's at least one object that belongs in both classes, but it doesn't tell us anything else, right? Is every member of the S class also a member of P? Or is that the only member of the S class that's a member of P? We don't know. Likewise, is every member of the P class a member of S? Or are there other members that are not members of S? We don't know, right? So neither term is distributed because we don't have sufficient information about either class. Now, this one tends to be the most confusing, so let's just look at it for a second. The O proposition will distribute its P term. That X placed in the S class outside of the P class does in fact tell us something about every member of the p-class. And here's what it tells us. It tells us that there is at least one object that is distinct from every member of the p-class. So, there we have it. Our properties of categorical propositions are quantity and quality. The property of terms within those propositions would be distribution, and we are going to have to remember that the Venn diagram is the entirety of the meaning of each one of these propositions.